In our second example, instead of being given the sample statistics, mean and standard deviation and sample size, we are given the actual data values. Now again, we have two independent groups. We're looking at wastewater treatment, and we have two different treatment plans, basically looking at different concentrations being used of the substance benzene. So we have our treatment 1 group, we have our treatment 2 group, again, two separate groups, and we want to know, do we have strong evidence to show that the mean concentration is less for treatment 2 than treatment 1? So this one is not looking at a specific just difference. This is looking at a definite less than. All right. So what I want to do is I want to think about what this would look like if I wrote it in terms of mu1 and mu2. Right? This says, how strong is the evidence that the mean concentration is less for treatment 2 than for treatment 1? And when we set up our hypothesis test, it is standard to state mu1 first and mu2 second. So even though this says the mean concentration is less for 2 than it is for 1, and I wrote that statement down, we are actually going to flip this to say, well, that means that mu1 is greater than mu2. All right, now remember, to run your hypothesis test, you need the sample mean, the standard deviation, and the sample size for each group. All right, one option, I could put this in Excel and I could calculate those values there. A second option, I could put this in my graphing calculator and calculate the values there. All right, I've got the graphing calculator already pulled up, so I'm going to use that option, but either one will be fine. I'm going to go to my stat list, so stat and edit. Remember, if you need to clear out your list, you put your cursor up on the name and you do clear and enter. And I have two groups, so I'm going to clear out list 1 and list 2. And I'm going to type in my values. So for treatment 1, 7.8, 7.6. 5.6, 6.8, and 6.4 for treatment 2, 4.1, 6.5, 3.7, 7.7, 7.3, 4.7, and that last one is 5.9. All right, the values I need again, sample size, which you can see here, sample mean, and sample standard deviation. In my graphing calculator, I would go to Stat, over to Calculate, and choose the one variable stats. All right, I'm going to run it on list 1 to start. I'm going to leave my frequency at 0, or sorry, not 0, I'm going to leave it blank, right, because everything occurs just one time. And I'm going to hit enter to evaluate. All right, gives us a lot of information, so you have to scroll to see it all. First thing you see is your sample mean. So X bar for group 1 is 6.84. If I scroll down a little, not yet. Standard deviation for the sample is a value of S. All right, I don't want population, I don't want sigma, I want S. And that's approximated here at 0.8989 if I round that to 4 places. And the sample size for group 1 is 5. If I do the same thing for treatment 2, all right, I'm just going to clear this out. Stat, calculate, one variable stats, but this time I need to change this. Oops. It's a little bit different on my iPad, sorry. I need to change that from list 1 to list 2. So to bring up list 2, second button and 2, I'm going to leave my frequency list blank and evaluate. Scroll back up to the top so I can see everything. My sample mean is 5.7. My standard deviation is 1.5706, if I round that. And my sample size for group 2 is 7. All right, so we've got the information we need from each group. We know what we're testing, and we're going to do this at a 0.05 significance level. So when I state my null and my alternative hypothesis, the null is still going to state equality between the means. But the alternative, in this case, will state that mu1 is greater than mu2 because we're saying the concentration is less for treatment 2. All right. Now, you'll notice these sample sizes are smaller, so technically here I would want to construct like a quick box plot or something like that just to make sure it's not terribly skewed. I'm going to skip over that part, let you know I have checked that, and these are approximately normal, and so my assumptions are being met. My rejection region, going to come from a T distribution, centered at 0. If I look at the alternative hypothesis, this time I have a greater than. So this is going to be a right-tailed hypothesis test. I'll shade in the right tail. I'll use alpha at 0.05, no need to divide by 2 here. And degrees of freedom, we'll take the smaller sample size, minus 1. And then again, you can go to your T calculator in the ALEKS calculator, or you can go to your table. All right, this time I want 0.05 and 4 degrees of freedom. That's going to give me a critical value of 2.132. Always double check your sign for a right-tailed test. It should stay positive. If this had been a left-tailed test, then we would have shaded on the left side, and thus that would have been a negative 2.132. All right, test statistic. I'm going to look at the difference between the sample means, 6.84 and 5.7. Technically comparing that against a difference of 0 in the population. And then I'm going to divide that by the standard error. So I'll take each standard deviation, square it, divide by the sample size. And all of that should be underneath my square root. All right, difference between the sample means is 1.14, and my standard error is approximately 0.7169, giving me a test statistic of 1.590. And then again, I go to make my decision. I just want to look to see if I am in the shaded region. And again, this is a situation where that does not happen. My test statistic is 1.590. That's not greater than 2.132. So because we are not in the shaded region, we will not reject the null hypothesis. And remember, in order to conclude that there is some type of difference, okay, whether it's, not equal to, less than, greater than, you have to reject the null hypothesis. So when you're not able to do that, you are always stating that there is not enough evidence to conclude that difference. In this case, there is not enough evidence to conclude that the mean for treatment 2 is less than the mean for treatment 1, which is the claim that we were asked to test.